Hello, everyone. Thank you for attending our session in the global workshop of Ontologies Commons. So I hope that technically everything is good if you are hearing me very well. So I'm Hedi Karray from National Engineering School of Tarbes in France. I'm the chair of this session. I'm also the technical coordinator of Ontologies Commons project. So before starting, so the session will be recorded. So during the talks, your mic will be and camera are deactivated. And after the talks, the discussion part will start, and then we have the possibility to discuss with speakers by asking questions via the QA function or in the chat. And also there is a possibility to raise your hand if you want and ask your questions with audio and video. So in this case, you'll be invited to the stage and so please, if you have questions, don't wait to ask your questions. Okay, so the scope of this presentation is the top reference ontology focused area of Ontologies Commons. So the main objective is really to develop the top reference ontology that will be an apical point of the Ontologies Commons ecosystem, and in which we'll develop a set of middle-level ontologies that will be the foundation for the lower level ontologies development. So the scope of this session is more about discussion on the vertical reorganization of ontologies by top, mid, and domain level. And we focus on what we call the stratification of ontologies, not only to help in modular development and reuse, but also provide semantic interoperability among domain-level ontologies based on generalization, unification, and abstraction of concepts, and to understand different stratification strategies adopted in different ontology development projects. So the objective is really to discuss potential criteria to identify vertical ontology hierarchy, for example, by or internal structure, and also to address using vertical stratification to characterize ontologies. So for that, we will start the session with 3 impulse talks from our invited speakers from different backgrounds, let's say that, from Industrial Ontology Foundry, from EMMO, and from Dolce-related development projects. So we are glad to have our speakers Aldo Gangemi from University of Bologna, Will Sobel from MTConnect, and Emanuele Ghedini from University of Bologna also. So our first speaker is Aldo, who is a full professor at University of Bologna and director of the Institute of Cognitive Science and Technologies of the Italian National Research Council, where he has co-founded the Semantic Technology Lab in 2008. So the research of Aldo focuses on semantic technologies and integration of methods from knowledge engineering, semantic web, linked data, cognitive science, and natural language processing. So I give the floor to Aldo to start his presentation about layered patterns in design workflow. Please go ahead, Aldo.
Thanks, Mohammed. Let's see if I manage to share my screen. I guess so. Can you see it? Not yet. Present audio.
Not yet.
Share screen. Entire screen. Okay.
It's coming. Yes.
Can you see it now? Okay. Okay. Can you hear it? Okay. I will try to give you my perspective on what happened with these ontology architectures along the last 20 years, but I will be very quick, actually. Don't be afraid. So this is my basic position, is that traditional ontology stratification is not a solid architectural principle. That's my position, that and we need to have a more complex, more realistic approach when we discuss these modular principles. So basically, the distinction that we have, for example, between top, mid, and domain ontologies is very useful mainly from a general guideline, an educational guideline. But it cannot lead to a good modular ontology architecture. Why? Firstly, because of its assumption. Top, mid are ways of claiming domain independence. But the problem is that domain independence is a sort of façon de parler. So when you have abstract, general, reusable predicates, and you apply them to a realistic use case, there is always some non-trivial mapping to be done. Consider that sometimes you want to organize parthood by inferential attributes of parthood. So going on the detail of the axiomatization you want to get at them, or by topological attributes, for example, how its parts connect to connection, or by the universe involved. So you are talking about what in your domain specifically, or by the locality or the same space occupied by time, etc. And the same with other important distinctions that are about containment or participation or abstraction, etc. So, when you map to the actual domain, you are actually making some choices that do not ensure that when you compare this ontology, that you're organized possibly in a stratified way, you are actually making the same assumptions as the other ontologies. Of course, even a foundation, it can be organized in different ways. So this sometimes can be a showstopper. The second reason is a bit simpler. That common sense can vary across domains. So I have this conviction, actually, that common sense is not just the knowledge that forks are usually found in a kitchen, but that common sense is actually everywhere. So you can have common sense in medicine, or common sense in product workflows, or common sense in business practices. And this is highly variable. So if you say mid, this mid could be positioned anywhere. Of course, if you consider core, the notion of core instead of mid, this could be a bit better, but because they are considering then core as the role of a certain module within your domain. And the third reason is that we have when multiple reused ontologies from the ecosystem of ontologies we want to consider, jointly with ontology that we need to align to, or extracted from legacy data models, or structured data sources, for example, from text, this will become pretty messy and more complicated, actually, because this actually allows to access relevant data. In a realistic project, this is very important. So I will make some examples, but let me conclude with the fourth one, which is the top-level predicates have a trade-off. For one, in my experience, for example, on one hand, they are used for interoperability, but in this case, the recall is higher proportionally to the broader axiomatization. So you may not want to be too specific. But when you want to provoke errors or to make a consistency check, of course, the precision is higher when you compare to the stricter axiomatization that you are supporting. And these are different consequences. On one hand, if you have a relaxed or fuzzy intention, this may lead to more alignment, but also to confusion. And this sometimes could be acceptable. For example, if you have a general notion of part without being too specific, or location, or organization, or inflammation in medicine, which is basically understood by physicians. But on the other hand, if you use very general notions and quite vague ones like mind or consciousness, this might be a problem, because you don't know what you're talking about, even if they can be articulated in a more specific manner. The second consequence is that if you have a crisp intention, very rigorous one, this may lead to exact alignment, but also to unwanted assumptions sometimes. You impose some pedantic check-ins. This was an experience we had when aligning the DBpedia data, not only ontology to Dolce. And actually, we had to make some approximations in order to make things work acceptably. So I would go back to 20 years ago, almost when we wrote the deliverable 18 of WonderWeb for Dolce. And there was a picture that tried to show you that stratification could be seen from different perspectives. So you can choose the vision, and the vision is actually the basic choices that you're making. So what kind of time theory or spatial theory, or and then you have another one, which is the specificity. Then you can have foundational choices, and then for example, a legal core ontology and the bank ontology. But the two things are not completely are not the same, actually. Hardly you can just use vision, so the choices of what we call nowadays ontologies and patterns, to decide what is the actual modularization. That depends on many other aspects. Indeed, you can have a clean case in which, for example, you want to distinguish things like process or part versus work of art, painting, and author, versus sculpture, mythical being, or caryatid, or Doric order, etc. But in realistic use cases, you have something like this. This goes back to 2006. Actually, there was slides that I presented at the Semantic Web Summer School 15 years ago. And in this case, for example, we had this fishery ontology service, and it required not to put to consider Dolce, but jointly with WordNet and jointly with some fishery core, but is intermixed with the other points. So it's hard to clarify here that there is a very clean stratigraphic view of our ontology projects. Now let's go to even more contemporary examples of modular stacks. So Ontopia is an ontology for Italian public administrations that we have developed, designed in a few years ago with a national governmental team for trying to create interoperability over all the Italian data. So quite an utopia, actually. But it works, especially the interesting thing is that the ontological part is still available, while the data part is now going into a different direction, not to accumulate everything in a super big data lake, but to look at APIs and decentralized services. But interestingly enough, here you have something that resembles a stratification, or you have a stack. But this stack, firstly, is a kind of a schematization, because things are a bit more complicated in reality. But you have this supporting level that is put there. It is not domain, it's not core, it's not maybe foundational, because in the supporting level you have these ontologies and distinctions that come from what we called in the Dolce deliverable as a vision. No? This may change, and this could be sometimes related to topic, but it's mostly about choices, really ontological choices that are to be made with reference to the particular use case. Another example is the ARCO. This is the ontology of the Italian cultural heritage that now contains a really huge amount of data. So here you have a more topic-oriented, but these topics are not actually topics of this history of art, for example, or cultural objects, but are more about the way they are organized and represented. For example, in the core ontology is actually more like more general distinctions, but when you go to things like catalog entities, or the description of the context of that entity in a certain archaeological workflow, or locations and geometry for localizing specific cultural objects or cultural events, you look like these modules are in the middle between the vision and the topic dimensions that I described originally. This is another quite complicated import. What results in practice, this is an example. This was an ontology built, a network ontology built for the data of the Italian National Research Council more than 10 years ago. And the import hierarchy could be quite complicated and not necessarily respects the stratification that we are talking about. This is another giant hub that we built, putting together a lot of different knowledge graphs that concern linguistic knowledge, but also factual knowledge and image-oriented knowledge. And things become even more complicated. Sometimes you recognize the fact that there are sub-stratifications, but it could be more complicated. So let me go Now, here you have a slide with a list of references that could be useful to understand this movement. There are modules and there are patterns, and now there is also some support for representing these internal structure of ontologies and their modules and their cultural conceptual components and the choices made within them. Of course, I don't have the time to discuss them here, but tomorrow morning, Valentina Presutti will make a presentation about these conceptual components that will be presented at KCAP in a couple of months. This is I conclude very quickly. This is the idea, that you have ontological entities that are constitute some ontological collection, and within this ontological collection, so the ensemble of the entities that are declared within ontology, you may articulate this ontology. You can see it in terms of modules or in terms of patterns, and those patterns can be implementation of certain conceptual components, or also known as knowledge graphs, and then you can have instantiations of these patterns in the data, and then you can reason with all of that, and you are able not to by using this OPLA X annotation language, you can really make your ontology more visible in terms of what are the actual vision or topic components that are inside it. So these are a few examples from Marco, but okay, you've got the point, and I don't have more time, I guess, unless there are no questions.
Thank you, Aldo. Thank you very much. So if you have questions, please you can put your questions in the chat. As also have the possibility to ask questions in discussion session. Maybe you can move to the second speaker. So William Sobel. So William has over 30 years of experience in information technologies and advanced applications architectures. He's currently leading multiple standards efforts, from industrial information and protocols to ontologies. So for over 13 years, he has been the principal architect to the MTConnect standard and creator of open source IIoT platforms for the manufacturing industry. He's also chairing the American Society for Mechanical enterprise standards development methodology working group, and also he's chairing MTConnect working group in the Industrial Ontologies Foundry. So William, please go ahead.
Hey, thanks a lot. Yeah, so what I'm going to talk about today is sort of a pragmatic approach to what we've been doing, not quite as detailed as Aldo. That's a really interesting talk. Thank you for that background. So the Industrial Ontologies Foundry is, their mission is to create interoperability between various different manufacturing domains with an open, free, principle-based reference set of domain ontologies. And I'm going to go quickly because also there's a little time. So one of the things I noticed when we were developing some of the domain ontologies within the IOF was that a lot of what we were doing didn't really resonate with a lot of the domain experts who were participating in the process. And one of the solutions, or one of the ways that we're trying to address some of these issues, is to stratify the development of the ontologies and put some layers in between, basically to put a core ontology and domain ontologies and structure them in such a way that we can allow the domain experts to provide their knowledge and their expertise in developing these ontologies. And so that we're not speaking only to the ontologists in the room, but we're also speaking to the domain experts. And this has been a delicate balance as IOF, or at least as I've observed IOF moving forward. I've had similar experiences in other standardization processes, like in model-based engineering and such, where the modeling piece of it sometimes is a little bit too complicated for some of the people who are not experts within that area. So one of the areas that we addressed this in was actually the IRI specification, where we started looking at some of the modularization. One thing that we looked at is actually not so much modularization per se, but looking at it more from a topic hierarchy, topic breakdown. So to stratify across topical areas and then create subtopic areas and then ontologies within those subtopics. The idea was from a release and a process perspective, because we're always looking at it from the process perspective, that the topics are going to be versioned together with a single date version number. The subtopics and ontologies are then within that higher level topic. And for some examples, we can have things like, the topic is a supply chain. We have a supply chain ontology, too creative there. But a little bit more interesting, like within core, we have meta ontologies, like the annotation vocabulary. We'll have events and observations and production planning and other ontologies. And we haven't really done the breakdown yet, but we found is that talking about it in terms of topics was an easier path than trying to talk about it as far as modularization goes. And it seemed to ease some of the confusion, because one domain can actually have multiple topics, and we can also have domains collaborating on different domain areas, working groups effectively collaborating on various topical areas and creating terms within those topical areas and sharing that that space, versus having to have a rigid domain to module mapping and then trying to collaborate within those constraints. From the ontological perspective, top down, basically we're IOF is based on BFO as our top level ontology, and below that we've explored a few mid-level ontologies like CCO. But regardless, we're putting this IOF core ontology as a boundary or a barrier to reduce some of the complexity of the top level ontologies, to provide patterns and guidance and stratification, so that when you get to the domain ontologies and subdomain ontologies, we're able to provide the common cross-domain abstractions that will allow these groups to become more efficient. One of the problems that you have is the domain ontologies can sometimes get very wrapped up in trying to figure out the nuances and the complexities of the top level ontology, and not get to actually defining terms within the domain, because the complexity and the modeling is difficult for us, the domain experts, to be able to manage. And sometimes even within the domain working groups, you don't have ontological experts within there, and they can't make all of the, they haven't come fully up the learning curve. So we're using some of the layering and the modularization as a way to be able to also protect or buffer some of the working groups from some of the higher level ontologies, but still provide the axiomatic and the and all the rigor that's required to enable those top level. So the core terms, basically this mid-level, is all cross-cutting terms. So what we've done is we've gone to all the working groups and asked them for all of their higher level terms, or terms that are their highest level of abstraction, and then find the ones that are in that abstraction layer that cut across multiple different domains. And one of the rules is that all of the core terms must descend from either a BFO or a BFO mid-level ontology. So every term that we create within core must be directly tied to the top level ontology. Second, all of domain ontologies and lower level topics must also then tie back into core. So core, all terms in the domain ontologies must refer back to a core term, which then provides that abstraction layer, the higher level domain abstraction layer, and also provides a terminology in a way that is more amenable to people who are in the manufacturing domain. And we also provide patterns. So the other key aspect of this is to provide patterns for creating common sets of ontological requirements to fulfill use cases. So in the cases of like roles, you'll provide role patterns and either define classes or other places where you can hang various terms off of that will give you those top level abstractions, a top level axiomization without having to recreate that every time you need it within each of the different working groups. And also then provide things like when you have, let's say, information that you want to be able to output from a process, to provide the entire chain of events and the relationships to things like the temporal regions, and then the temporal regions to the information content entities, and information content entities, information bearing entities, et cetera, and tying all those patterns together so that at the domain level, we can talk about the higher level patterns and not have to talk about some of the detail that it takes to be able to get a value out within something like a BFO framework. For example, here's an observation pattern that we have. And as you can see, it's pretty complex. This is just to be able to observe something happening within a piece of manufacturing equipment. There's a lot of individuals created. There's a lot of relationships. What we want to be able to do is create a set of patterns that will help to facilitate the use of these higher level concepts without having to put the burden on each of the working groups to be able to recreate those. So the core is going to be made up of a combination of both patterns and those core terms that everything else can hang off of. And that will hopefully add to some of the, increased agility and increased performance within some of our working groups. So these top level what we found is that top and mid-level ontologies require a lot of rigor and formalisms that are often not comprehensible to some of the working groups. And we can buffer that. We can make them comprehensible by also adding additional labels to some of the terms so that things like continuant, specifically dependent continuant, generally dependent continuant, some of these terminologies that are used within the top levels are renamed or redefined or relabeled for the domain experts and the domain people so that they can understand what we're trying to get at and what is actually being conveyed by some of these top level abstractions. And we also will provide some lower level formalisms because a lot of the top level universals are elucidations, which means that they don't have necessary and sufficient conditions. So we want to add additional axiomatic constraints in there. And we also need to deal with some of the 3D versus 4D, realist versus partial realist, which BFO is a realist ontology. We need to get into things like abstract processes, software systems, financial systems, algorithms, and process parameters, which really sort of push the boundary of realist. So we're trying to figure out how to model that within core so that we can create some of these higher level abstractions to be able to provide the building blocks for our domains to function efficiently. And one thing that we are now working on within core is sort of the domain and the boundaries of core now really constrained by what the capabilities of the top level ontology are. So when you pick your top level ontology, to a certain extent, you're constraining everything else. So we need to work within those constraints and figure out how the best way to model everything, given, like in this case, BFO and their way of providing a realist framework. And then we need to make sure that we can address these abstractions and provide the patterns so that our domain ontology creators can be more effective. and then create all the axiomatization as much as possible in that core layer, so that again, you're just using some of the axiomatization, the constraints and such at the lower levels with the various different relations that we created, and not having to recreate a lot of that complexity when you're actually trying to just define your domain terms. And then we need to work on how we can work with other ontologies like FIBO for things like supply chain, where we're going to need to talk about things like financial transactions and the governance and corporate relationships and structure and ownership and such. So there are other ontologies that we're going to have to figure out how to bring in that may not be necessarily compatible with some of our TLO choices. So that's going to be some future challenges that I think we're going to need to go with. But we've decided on how to move forward in the strategy and how to build out the core ontology in such a way that we can hopefully facilitate some further development within our organization. So that's about it. A little bit over. So,
thank you.
Yeah.
Thank you, Will, for this insightful talk. So I don't see any questions in the. Yeah, there is a question from Roberto Rovetto. So he's asking, what if users do not agree with the content and assumptions of the top level? Have you considered simply using the industry-specific IWF layer, that is, avoid using a top-level ontology?
Oh, yeah. Yes, we went around a decoupled version of the IWF ontology and trying to just separate out the terms and make something that can be used with other top-level ontologies and work around those assumptions. That kind of tied us up in knots. And eventually we decided that we had to make the ontological commitments and choose a top-level ontology and work that direction first before we were able to create a TLO independent or decoupled version. And I won't get into the details of that conversation. I was one of the people who worked on the decoupled version and tried to create something that was less TLO-centric and worked around some of these issues and some of these constraints. But at the end of the day, I think the feeling was that it would be too difficult to bring that decoupled ontology back in line with our top level BFO, and therefore it was better to go the other direction first. So we're actually taking now the decoupled terms that we created, because we did it more from an architectural approach, top down, versus sort of looking at various different terms from the domains and then trying to bubble them up, taking that architectural approach and then bringing it back into and mapping it to BFO, and then parking some of the terms that don't quite fit into that top level ontology. So hopefully that answered the question.
Yeah, so there is, I mean, he's replying to you, he's asking, why would you need to get it back in line with any top level? So this is the question of fraud.
Because IOF from the beginning is committed to using BFO as a top level ontology. That was a decision made, I guess, quite a few years ago, that BFO was going to be the top level ontology. And given that requirement, there wasn't really a different direction that we could take. It's a decision that was made even before I joined IOF. So it, to a large extent, constrained us as far as how we could move forward. So we're trying to move forward in the most effective way possible right now to be able to get some usable ontologies out to the industry.
Yeah, this is also one of our, let's say, discussions in this morning session with ontology matching, ontology interoperability, and speakers highlighted the added value of top-level ontology to facilitate alignment and matching between ontologies. So there's other questions, but maybe we will answer those questions later in the discussion, in the panel. So let's move to the presentation of Emanuele Ghedini. Emanuele, he's associate professor at the University of Bologna since 2014. His research fields includes plasma transport theory and the development of physical mathematical models for industrial applications of plasma. So his main research interests are in calculation of transport properties of plasma, modeling plasma, and he's working on ontologies and top-level ontology EMMO, the European, in the scope of the European Materials Modeling Council. So please go ahead, Emanuele.
Okay, good afternoon. Thanks for the introduction. I'm going to show you some insights about the EMMO structure and perspective. So we started the developing of the EMMO by understanding that interpretation is a very important part of the ontological work. And we realized also that there exists several conceptualizations for the same thing. So every human being has its own different definition for every single term. And this is something that we have to deal with when building an ontology for a specific set of users. For example, we have even conflicting standards when it happens that we need to define what a product is. So this type of different pluralistic interpretation of a term, in this case, the product, happens even when you want to follow ISO standards. So the solution for this type of issues is not to fight against pluralism, but it's to embrace pluralism. And doing so will also be in line with the human-centric approach that is the foundation for Industry 5.0. So embracing multi-presentation of the single real-world object is what is the foundational principle behind the EMMO. So we can build a gateway for the human-to-machine and machine-to-human interaction. In order to do so, we have to build a really agnostic ontology framework that is able to host several and different vocabularies with some overlapping entities and some maybe also some incompatibilities. So that's how and why we developed the EMMO, the top level of the EMMO, that, as you can see, is extremely simple, but still is rooted on the principle of physics. I would like to say that we use inspiration from Feynman diagrams, so the interaction between elementary particles to bubble up a causality system that goes that also recreates time and space, and so it is strongly rooted in the applied science domain. It is simple. It is based only on Merovingian causality, so we have two types of primitive relation. It is a very flexible tool to describe objects at every possible scale, so from the quantum blob to the universe. It provides an agnostic base for pluralistic representation of objects. It provides space and time topological relation as defined, not primitive concept. In fact, all the entities here are defined except for the two relations of partude and causality that are primitive. So given these two concepts, everything at the top level is completely defined. And it is also quantum mechanics 3D, so it can be used to describe system under quantum mechanical perspective. So, but this is not the full principle behind the EMMO, because what we embrace is full nominalism and physicalism. So we say that real-world objects are always 4D, are always material and representable through causality and partude. So we drop the abstract concept because we want to talk about things that actually exist. So in order to avoid any type of misunderstanding about concepts. So we don't want to ontologize abstract entities. Instead, we use classes as a collection of real-world objects that play the role of what abstract entities, abstract individual plays in other ontologies. So we have found that nominalism and physicalism are a great way to clear the way of misinterpretations. So perspectives are another important part of the EMMO, because as you can see, an agnostic top level is not enough to describe the world, because actually this top level makes no assumption about what exists between the universe and the quantum blob. So the EMMO asks you to put your perspective in place in order to build a categorization of things, which is usually subjective. So you can see here some of the perspectives that we created and use in the MMO, building our domain and application ontologies. An example of two perspectives are the persistent and holistic perspective. So in the persistent, we use a covering action to say that every real-world object is either an object or a process. So object and process distinction in the EMMO is actually due to a cognitive bias of the observer. So because in a 4D approach, which is the one of the EMMO, there is no actual distinction between the two of them. And at the same time, you can use also the holistic perspective to categorize the thing in terms of the whole and the part, and consider a whole be something that provides you more than the part. For example, a gas is a sum of molecular parts, but a gas is not only that. A gas possesses also viscosity, which is something that molecules cannot, that doesn't possess. So in this sense, we define the holistic branch. And if we combine this perspective, we have it opens up with a wide range of very interesting definitions. So, for example, a participant is a spatial object part. So, spatial, we are using the top-level ontology relation. So, a participant is an object which is a part of a whole, which is a process, or a component is an object which is a spatial part of an object whole, for example, and so on. So, we can build a lot of very easily some useful, very general definition by using these perspectives that are defined by covering action. So each perspective is a covering action that expresses the world in a set of specific subconcepts. Another example of the materialism. So if you say, if an ontologist in the MMO say "I love you," then the MMO asks to prove it. So in this sense, if you want to find the class of objects that express love, so we have no absolute thing. So what you have to do is to declare something, for example, as an object or as a process that may consider act or things that express love. In this sense, we define. It says we apply nominalism and materialism to this ontology in order to force an accurate declaration and avoiding ambiguities typical of abstract concepts. So this is a schema that shows you how the MMO is related to a specific individual. So we have the top level, which is an expression of mere topological agnosticism. So everything is defined except for causality and partude. Everything is completely defined, and you can use this to describe the things in their naked mere topological characterization. So I think is a causality change or a causality chain of quantum or elementary particle, for example. You can do that. So you can describe things in this very, very simple and naked way. Or you can use perspectives, for example, which are a covering action. So you can say that something is an object or a process or a whole made of part and so on by using the perspectives that are covering action and introduces some primitive concepts. Or you can introduce the discipline, which probably they are something more near to the domain level ontologies, in which you don't use covering actions, so they don't claim to describe the overall world like the perspective do, but they also cover a simple subpart of the universe, and they can rely directly to the top level, or they can rely on some perspective. For example, we have the manufacturing domain ontology in the MMO that is based on holism, because it's extremely to holism and persistence. So object, process, whole, and part, because we consider holism and persistency as a fundamental perspective upon which manufacturing is built. So another example is the data description in the MMO. So we have, you can see here, we can create an individual that is the value, so a number, like for example, 1 kilogram. And we can express this value in many different ways. It can be 1 kilogram in a sense of a syntactical construct that is compliant with the International System of Units. Or we can consider 1 kilogram like a data type. So for example, a scalar or a vector of value and so on. Or we can consider this 1 kilogram being potentially a description of the property called mass. So if we combine all of them, the same individual, so 1 kilogram, can be described in different perspectives. In this case, are more discipline than perspective. And then you can connect this through semiosis, which is another important part of the EMMO. You can connect these things that you describe semantically, syntactically, and in terms of data type to a specific object, which is the material. So my entity, my object that I have on my desk weighs 1 kilogram. So this is how we combine this perspective together. So another example, perspective have always something to say about the word object. For example, if I have my book, this can be seen as a solid, as an aggregate of something else in a physicalistic perspective. Or if you combine physicalistic and reductionistic, you can create a hierarchy of partud, book, pages, paper, fiber, and so on. If you combine symbolic and reductionist, we can build formal language description. So book, chapter, paragraph, words, symbol. If you use semiotics, we can see the book as a sign that stands for the life of a person, if it is a biography, for example. Or holistic and persistent together, we can consider the book as a whole and an object. So this is how we can use perspective to describe a specific object directly. Or you can use discipline. If you use discipline, then there is no ambition to cover the real object, but we are implementing the knowledge of a specific domain, and then we can, for example, define the discipline of books, and we can also declare some classes that can describe, categorize the book according to the book binding, the language, the ligature, the age, the content, the paper material, and so on. So, and that's also the discipline in the EMMO are branches of ontology that channel the interpretation of an entity toward a specific domain of interest. So they have no covering action claim, simply they are propose an interpretation. So the conclusion, so the EMMO is more about pluralistic parallelism, representing things in many different and coexisting ways instead of serial stratification. So things that are represented in one and only way, because we realize that that's not the case with people. So people doesn't want to embrace one and one only view. They want ontology to bend and to describe their way of seeing things. And the focus for the EMMO development is on capturing the multiple ways in which a real-world object is expressed by communities. And in the EMMO effort, a distinction between perspective and discipline, which can be connected to mid-level ontologies or domain-level ontologies, is proposed using the covering axiomatization for the perspective, leading to a hierarchy of discipline with a combination of parallel and serial dependency between the modules. And that's all. Thanks for your attention. And the EMMO team is made of not only of me, but of other very important people that you can see here.
Thank you. Thank you very much. Great. Okay, so let's back to questions. And so firstly, Aldo is sorry he has to leave. So I think we have other colleagues from Dolce related projects that also can interact with us in the discussion session. So let's back to IUF. One of the questions for you, Will, is about CCO, Common Core Ontologies. So to what extent are you using the CCO, and which parts have been replaced by the IUF core?
Well, we've only looked at a few areas for inclusion right now, or investigated, mainly around the information content entities, effectively the descriptive, designative, and directive. I think the primary areas that we've looked at, we haven't specifically added any of the CCO terms to IOF at this point in the core. We're still working on some more fundamental abstractions that are not included right now in CCO, but for some of the information areas, that was our main area of interest at this point.
Mhm.
Did that answer it?
Okay, all right. Let's, I mean, if there is no questions from the audience, I have one, let's say a little bit generic one, is about the criteria that emerge from the usage, from your experience, to identify this vertical hierarchy for ontology. So how we can define the criteria in order to, if we took another in a domain or in another area or in industry, how we will choose this hierarchy of ontology. How to say, okay, we have a top-level ontology, but have this mid-level ontologies to develop. So what are the criteria to select this?
Manuel, do you want?
It's for both of you, Emanuele. Yes?
Yeah, no, I'm just joking.
Okay, should I take the burden?
Go for it.
The $1 million question.
Yeah, there you go.
I think there are no answer to this question. It's not a question for the domain expert. It's a question for ontologists. For the domain expert, in my opinion, are okay with taxonomies. So they mostly consider this, in my opinion, as the most important relation that, and then they deal with, they ask for a very abstract connection between things that populate these taxonomies. And so for this reason, I think that the distinction between mid-level and domain level is more something that has to deal with how do you want to conceptualize, to build the conceptualization of these domain ontologies. So I think that the top-level ontology is needed when you want to start to build a conceptualization, meaning you want to start to build a logical structure that helps you to put the domain ontology on steroids. And this can be extremely different. So this logical structure can be extremely done in many different ways. So the BFO has its own way to create this logical structure. The EMMO has its own way. Dolce has its own way. The taxonomy will remain almost the same because it's related to interpretation. So a product is something like that according to this community, and this should be true for all the top-level ontologies. But how do you define this product related to other parallel forest of trees that are other taxonomies? This is done by different logical system that comes from a different top-level ontology, in my opinion. So the distinction, so answering your question, the distinction to me is more related to the logical framework you want to use that is related to the top level. Because in my opinion, domain experts are happy enough with taxonomies and a small set of relations.
Mm-hmm.
Mm. Yeah,
Well,
I'd agree with that.
okay.
Yeah, I mean, from a domain expert, we're trying to, as well, as standards developer, I mean, it's kind of where I'm coming at this from. We're trying to extract their knowledge and their experience and make it so that they can express themselves in a way that we can then capture that knowledge and build terms and definitions around that. And then the mapping to whatever top level or domain ontology is then going to be the activity of the ontologist to be able to take those definitions and those terms, which are pretty much, I think, as Emanuele was saying, they're free floating. They're not tied to one particular perspective, and then bring them in. But what we found is that we have to find ways of making that more efficient. The process of collecting the definitions and being able to allow for the for the domain experts to be able to express themselves and be able to interact with the process without getting overly concerned about the details of how to build the ontology and how, what are, to understand, for somebody who's a domain expert or somebody who's not deep into this, to understand all the nuances of BFO or any of the top level ontologies, Dolce or anything, and to be able to then operate within that constrained environment is very difficult. So I think one of our objectives is to be able to figure out how to make that a more fluid process so that we can get them to participate in these discussions and find an efficient way of being able to collect this information. I don't think from a stratification perspective, they really care. I agree with what Emanuele said. I don't think they really care about how things are organized. I think that's more of an architectural concern. And as you would even, we have similar things that go on in information standards where we, the architectural concerns about how we modularize things, how we structure the information, how they're related to each other aren't really the domain experts' concerns at all. They just want to be able to represent their information and be able to do something valuable. How do I get value out of this information or out of this model or out of whatever we're building? And how can you find a path to creating value from this high level of complexity, which is really some of the issues that they have, is being able to make that leap.
That's great. Okay, I have also another question. I'm usually wondering. I mean, maybe as you said, from domain expert perspective, which is more important is not this vertical stratification, but the horizontal linking between ontologies. And my question is more about what is, I mean, let's say this vertical and horizontal linking between ontologies is if this stratification, if there this vertical linking can have a big impact from the practical point of view on this horizontal linking between ontologies, between cross-domain, let's say that, or even in the same domain, but from practical point of view, if in the same domain I have two ontologies, is the stratification to understand this link in the vertical, in the horizontal link, in the horizontal layer, let's say that.
Sorry, I missed your last sentence, Hedi.
Yeah, I say, I mean, the stratification, the impact of the stratification of this vertical linking between ontologies with the horizontal linking between ontologies in the same domain or cross-domain.
So you're saying, so if I understand you correctly, how does the stratification help in the linking of various different domain and cross-domain ontologies and building that out? Yeah, I mean, just having the common set of terms at the higher level of abstraction, being able to, I mean, one example that we're currently working through to kind of bring it down to reality is things like a maintenance ontology and from my perspective, the MTConnect one, which is basically observations of equipment and information or data that's collected from equipment as it's operating, the operational states, the functions, the capabilities of that equipment, and then having a common way of being able to express those abstractions of here's some data that we're collecting, here's how we manage it, here are some events that occur that we can find that we observed happening on the piece of equipment, and this is how they affect the piece of equipment's ability to perform some activity or have some capability, and then how you build the capabilities of the equipment and then sync them up with the maintenance of that equipment to be able to restore those capabilities. So to cross those domains, and then let's take it one step further. Let's go to process planning. If I wanted to take the maintenance and the observation models of equipment and then take them over to process planning, I'd need a common way to be able to talk about the capabilities of the machines, the capabilities required by various different production processes, and then scheduling them for when they're active and inactive, and when they're, when they're going to be performing certain processes in the future. So planned processes, etc. So schedules, scheduled maintenance, scheduled downtime. Again, common concepts of scheduling and planning and processes that are going to occur at a certain place in time at a certain piece of equipment. So it's just around sort of equipment ontologies, but each of those different subdomains, maintenance, process planning, scheduling, production, and equipment observation, and states and capabilities, all need to have some common foundational terminology so that we can cross over and connect up those points. Otherwise, if we were doing just sort of separate verticals, it'd be very difficult for us to be able to say, I've observed some problem here that is then going to trigger some loss of capability. That loss of capability is then going to affect my process planning and my scheduling, because now I don't have the capability to be able to run that job on that machine. So I need to cascade that all the way through and tie all those pieces together. Going further on, if we want to cross domains and life cycle, again, sticking with industrial, we're talking about things like, engineering and design and such, and where can I make certain things, and talking about supply chain and logistics. We can then expand out and go even further afield if we have, again, higher levels of abstraction across multiple different domain ontologies. So being able to tie these concepts together allows us to bring together these, what would be seen as almost disparate domains, from geometries down to production planning, scheduling, execution, capability, etc., and then be able to talk about those in some kind of a cohesive way.
That's great. Emanuele, do you want to add something here? Or
Yeah, I would like also to add to focus on not only on classes and taxonomies, but to focus also on the hierarchy of relations that we use to connect things. Because what we realized by writing the MMO is that if we have two primitive relations, in the MMO we have three, which is partured, causality, and semiotics. It is much more easy to build a scalable expressivity, meaning that, for example, you can connect two non-connected trees, taxonomies, for example, using the higher part of the relation hierarchy. For example, partured can be used to connect two trees, taxonomical trees, in a very general way, in a way that it is compatible with most of the existing ontologies. And then if you specialize your relation, then you can go down and be committed to a more specific domain or to a more specific top-level ontology. So, for example, partured can be specialized in the MMO in many different ways that maybe it cannot be found in Dolce or in BFO or other ontologies. But partured you will find everywhere, in almost every ontology. So I think that focusing and investing a bit more on the relation hierarchy and how to use the relation hierarchy to define the distinction between the top, the mid, and the domain level is something also that we should investigate a bit more.
Mm-hmm. Okay, thank you. I have two questions from the chat. First one is more, let's say, a comment from Robert about, I mean, perhaps it shouldn't be so constrained. I mean, to be forced to use a single top-level ontology. This is maybe it's join what you said, Emanuele. And also, I mean, there is a question, but I will link it because Arco is asking what are the most important top-level and mid-level ontologies that the domain practitioners from materials and manufacturing should consider. And this is the question. I mean, should consider from one top level, multiple top level ontologies, and to create bridges, because even those mid-level ontologies can be under a top level ontology. So the question here is, let me generalize the question of Arco and also the comment of Robert is, what are the most important part of knowledge existing in ontologies that a practitioner in from material manufacturing should consider or can find in available and can be useful for him?
I mean, I haven't run across a huge number. I think one of the ontologies that came out a while ago was like a PSL, which dealt with more of the production planning and scheduling areas of it and process. I haven't seen a lot addressing the manufacturing domain from an ontological perspective. I know there are some that are working on, like I think through ISTM, they're working on some of the materials and such. But I mean, IOF was really stood up to address a lot of the mid and domain level ontological development within manufacturing, because to a large extent, it really wasn't available, or there wasn't anything that was really prevalent in that space. Regarding top level, it's difficult to say that one would have to have a top level ontology. I mean, I know that this is a very loaded discussion, and you get very strong opinions on whether you need to have a top level ontology, or else you can do it like what Emanuele's saying, through relationship hierarchies. Often when we talk about, like in IOF, we talk about terms, we're talking about through relations and universals. So they're both classes and properties. So we're talking about both concepts in the same term. But I don't personally, I'm speaking for myself now, I don't, I'm not convinced that having or constraining oneself to necessarily a top level ontology is necessarily the best way to go. I think for the IOF, that was the decision they made, that you have to go with your decisions, you have to keep consistent. But from a purely architectural perspective, being able to then unconstrain yourself and map to other ontologies or avail yourself of what else is out there, I'm not sure if the trade-off between being constrained to a single viewpoint and a single way of looking at the universe is necessarily better than giving yourself more options. So to Roberto's point, I'm going to say jury's out, from my perspective.
Emanuele?
Emanuele, you have your opinion on that.
Well, my opinion, it comes from the experience of the MMC in this field. And I would say the one that you find more suitable for your mind, for for your community, which relies on the definition that you find more easy to connect to real-world entities in your experience. I can tell you, for example, that I found very interesting the Hedi ontology. I found very interesting the OntoCape ontology. I found they're very nice ontology, but they are tailored to something, to a specific perspective view of the things that they want to represent. In fact, as EMMC, we didn't find any ontologies that were suitable for our needs, that contained all the, the possibility to describe material in terms of granularity in a very precise way. So representing a material as a tree, a direct rooted tree, to navigate with multi-scale modeling, it was impossible to find something like that. So we had to invent, with the help of Achille Varzi, a way to do that. And then we also we had nothing about modeling. So how can a model be connected? And what is a model? Is an equation? What is it? So we had to invent a completely new way to describe our domain, starting from from the semiosis, so from the interpretation, so as things stand today, I would say the one that you find that that is more easy to understand, and if you don't go for a top level. That's it. If you are interested, as the EMMO, we are starting to build an ontology according to the requirement of the community. So we have several European projects. So it's a huge exercise that start to build the top level from the bottom. So from the and we revise every month. We have to revise some of the MMO in order to be more expressive and more understandable from the people working on the field. So this is our exercise that I think it is really important to do in order to create an ontology that is tailored for a specific purpose. And implicitly in this in these sentences, there is the fact that we don't claim that there will be only one top level ontology suitable for every human being. So an ontology should be tailored to specific cognitive bias, should be flexible enough to cover most of the things that are around this cognitive domain, but there are communities that are happy with far less than what we are doing in the MMO. So that's it. Mm-hmm. Maybe it's a weak position, but I think it's the only one that I honestly I want to sustain now.
For honest,
you're breaking up.
Sites and sorry.
Hedi, you're breaking up a bit.
I don't hear you very well. I have a bad connection. Sorry. Do you hear me?
Yeah, now we do.
Yeah.
Okay, that's great. Okay, so I would like to thank you very much for your insight and for this great discussion. I would like also to thank the attendees for their questions, for interactions. So thank you very much, and I hope to see you and to discuss with you in the other sessions of this workshop. So other sessions will be run tomorrow, Thursday and Friday also, so all of you are welcome to attend. And by the end of the day, I think at 4th there is the summary session in which we'll present the summary of all the sessions of this day. Thank you very much, and talk to you and see you soon. Thank you. Bye-bye.
Thanks a lot.
Bye. Thanks.
Bye. Thank you.